Hello, I'm John Joshua Bilonia and I'm back again with another Python experiment video. In this experiment, number 6, we'll be exploring loops, break, continue, while, and lists. So first, we'll be exploring the loop. We'll be used to familiarize to it and execute it in real life situations. So basically, we should be, in this scenario, we should have an expected output of here as have a context of counting from 1 to 5 in the context of hide and seek. So this is time sensitive, and in order for us to do that, we have been provided with this code import time, and then we will reconstruct our code based on that. So here's our expected output. Let's have it. Now, import time. Then I'll assign a variable of I is equals to 0 just for reference. And since you'll be counting to 5, I'll use a for loop for I in range 5 because you'll be counting 1 to 5. Let's print the expected output that you have been expected to have an output of 1 Mississippi. So the first I is 0, but we'll be expecting 1 Mississippi. So I plus 1. So I plus 1. Then we'll add the word Mississippi. After that, we have been provided with some type of, I don't know what this is, but it's a given. Yeah, it's given here. And after counting, we should be printing ready or not. Here I come. As indicated here, ready or not, here I come. So after counting to 5, it should print. So let's see if this works. 1, 2, 3, 4, 5. Ready or not, here I come. So wow, that really has a time element in it, isn't it? It has a delay between the iterations of the for loop. So that's what is meant by time that sleep. Then 1, I guess it is seconds, I guess. Moving on. Oh, copy the code. I'm copying the code. And here is the code. Not in bold, just okay. Part 2, the break. The break statement inside loops. So basically, the break statement is used to exit a loop. So in here, we'll have a design program that it asks you to enter the secret word, secret, but if you do not enter the right secret word, you will not exit the loop. So basically, it's a while loop, I guess, because while you do not get the secret code, you will not exit. And in order for us to exit, we'll use the break because it is demanded. So let's delete this. So we have my favorite variable x is equal to the input of the user, and I'll have them please enter a word in all caps. Why am I asking in all capitals? Because the secret word is all capitalized, so it should be inputted in all capitalized letters. So I'll assign a variable a equals to 0 and then construct the while loop that while a is not equal to some value, let's say 1, you should not be able to exit. So here, if a is not equal to 1, the player should be asked to input again. So just copy this. So input again. But if the code is equal now to the secret code, then we should be able to break 1, 2, 3, 4, break and go outside of the loop. We have here, you've successfully left the loop. You've successfully left the loop. Okay, so as we can see here, the break was intending to go out of the while loop in order to execute the next line of code, which is outside of the loop, that is a print function. So let's try it. Oh, right, we should have colon there. Yeah. Okay, one more try. Uh, let's try the word secret, but not in all caps. Yeah, it doesn't work. But we enter random, random, random. In all caps, random. I mean, should play. Now let's enter secret in all caps. You've successfully left the loop. Okay, so our code is running. So let's write code here. And then observation. So basically the break immediately stops the loop, the while or the for loop, whatever the loop that is. It is included and proceeds to the code outside of the loop. As we can see here, what is outside of the loop after the break is the print function. So it executes the print function if the conditional is met. Okay. Part 3 is continue. Continue statement in loops. So the continue statement is used to skip the current block and move ahead to the next iteration without executing the statement inside the loop. So basically, the next iteration is the next attempt, right? So if you have a loop here and then there's a continue here, it would just return again to the top, then proceed. That is the continue. So the break would be outside of the code, after the loop, but the continue is just inside again from the start. Start again from inside of the loop. So that is just the continue. So basically what the scenario is, we are asked to enter a word and then we use this command to convert it to uppercase, and then we use conditional execution to eat the vowels from the inputted word. Print the uneaten letters to the screen. So basically we have like Gregory. So to eat the vowels is to remove the vowels. So we should just print the consonants and the vowels would be not printed. So the idea here is, if the letter is a vowel, continue, so that it would loop again. So if the letter is not a vowel, it would just print. So with that in mind, we can, yeah, we have the for loop for letter in user word. Okay, but first let's prompt to input. So I'll keep this first line. Oh, but it has the user word. Okay, so let's delete all that. So user word, oh, user word equals, so I'll have it on string. So string of the input, let's just say enter a word in small caps, I guess, or let's just say enter a word, and then we use the command here, to convert it to upper cases. And then we use a for loop, and it is a letter in user word. So if the letter is a vowel, let's say A, capital A, because it is capitalized by that function. So we use the continue statement. So basically we just repeat this, but for every vowel that we have, 1 2 3 4 5, just replace this with E, and then I, O, and the vowel U. And if it bypassed all that, we should be able to print the letter, right? So we have uh, incorrect syntax. Oh, we have colon, 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 colon. So let's say Gregory. As we can see here, GRGRY. So it just printed the consonant. So abstemious. Let's okay. What's that word? Abstemious. We see no vowels here. It's good. So how about IOUEA? Let's run it. Capital IOUEA. It should return none because those are all vowels. Yeah, it returned blank. Okay, so our code is good. So I'll just put on the code here. So part 4. Where part 4 on? Part 4, while. So basically this is the while loop implementation. And we have a situation here where a boy and his father is building a pyramid. But the pyramid has a principle of that each lower layer contains one more block more than the layer above. So as illustrated here, the bottom layer has one more brick or one more block more than the layer on its up. So in short, in essence, it is a Fibonacci sequence, of course. So okay. Okay, so our task is to write a program which reads the number of blocks the builders have and outputs the height of the pyramid that can be built using these blocks. So for example, we have 6 blocks. If I input 6, it should be output a height of 3. But here's the catch. Note that the height is measured by the number of fully completed layers, meaning if we only have 5 blocks, we have incomplete here, so it would just output a 2 height. If the builders don't have sufficient number of blocks and cannot complete the next layer, they finish their work immediately. So yeah, that's the so this is a bit tricky because we have Fibonacci sequence, and if the next Fibonacci number would not be fulfilled, it should be cut. So basically we are determining here is what is the number of that number in the Fibonacci sequence. So for example, 6 is the third number of the Fibonacci sequence. So basically, the blocks is the height of the Fibonacci sequence. So 6 blocks, the 6 is the third number in the Fibonacci sequence. So they have already provided here that blocks equals integer input, enter the number of blocks. Let's go. So blocks equals integer input of what? Enter the number of blocks. Enter the number of blocks. And then we write our code now. So let's say let's just rename the variable because it is too long, so let's just call it b. B is equals to blocks. Good. And then another arbitrary I feel we have to have arbitrary variable here, of course. And then block, and then the height. yeah, the height. Let's just abbreviate it as h. Initially 0 because the height is initially 0. So what I'm thinking of is we construct a Fibonacci function inside a while loop. Tama ba? Because while the blocks is greater than the Fibonacci number, it should continue. But if the blocks is not sufficient or is equal to the Fibonacci number, it should stop. Okay, so let's go with that idea. So while the blocks is b is greater than the Fibonacci number, we don't have that, right? Because height is the number of the nth element. So we have another arbitrary variable there. So let's just say a. So while the blocks is greater than the Fibonacci number, and then inside here we should develop a Fibonacci sequence where the height should be progressing one at a time, and also the blocks or the Fibonacci number, because the Fibonacci number is equal to the initial height 0 plus 1. So the Fibonacci number is equal to the initial Fibonacci number, which is 0, and our a is 0, plus the height, so that as we go further, the second number that would have just compiles and compiles, because it's hard to explain, but if we imagine, yeah, because as the height opens, so that is the h here is the number of blocks in that particular level. So in the first level of the Fibonacci, we have only one block. So yeah, and then it progresses as the Fibonacci number expands. Okay, nice. Okay, and then what now? We should put an else here. Else height we have input that height is equal to h, and then we should print the height. What is that again? The height of the pyramid. The height of the pyramid is the height of the pyramid, colon, space, and then height, the variable height. Yeah. Okay, let's see if we input 6, 22, and so if we input 6, it should return 3. Single S. If we input 6, should get 3. Nice. And if it is 25, if it is 20, if the input is 20 blocks, we get 5. But we have 6. Oh, because we have the condition of if the builders cannot complete the next layer, they finish their work. So we need to insert something in between here. An if function, I guess. If b is less than a, because if it is incomplete, it is not equal. So by that logic, if b is less than a, because if it is not equal, it is not complete. It should be equal, so that we will move on to this else. But if the blocks is less than the Fibonacci number, which is not completed layer, then the height should be -1, right? Height is equal to h minus 1. And then we copy this. Let's see. Input 6, we get 3. Input 20, we get 5. Okay, it's working. Input 1000, we get 44. Input 1000, we get 44. Good. Input 2, we get 1. Input 2, we get 1. Okay, all clear. All clear. let's copy this code and paste it right here. No. Okay, observation. So the code is in essence testing for a Fibonacci sequence as mentioned. A complication may arise if the condition, if the builders don't have a sufficient number of blocks and can complete the next layer, they finish their rigidly is ignored. So if we ignore this, we will just resort back to, that previous mistake if we ignore that. So this would result to incomplete layers being counted. Yeah, that is the effect. So part 5, lists. So basically, we have the condition here that we have a hat list here composed of the elements 1, 2, 3, 4, and 5. And we should write a line of code that prompts the user to replace the middle number, that is 3, in the list with an integer number entered by the user. Okay. Write a line of code that removes the last element from the list. Remove, okay. Write a line of code that prints the length of the existing list. Okay. Let's do just that. So we have hat list 1, 2, 3, 4, 5. We have hat capital hat list equals bracket because it is a list 1, 2, 3, 4, 5. Hat list equals to 1, 2, 3, 4, 5. Write a line of code that prompts the user to replace the middle number. So okay, let's first so as we access the list, that is the middle of the list, that is 2 because this is 0, this is 1, this is 2. So the middle, which is 3, is 2. So the hat list 2 should be replaced by the integer input provided by the user. Input provided by the user. So let's just say enter a number. And then, so that is the first condition. The second one is write a line of code that removes the last element. So remove the last element. Okay, so we just have hat list remove the element 5. I mean the value. We can also use hat list dot pop, but let's go with just this so that we will remove that. Okay, and then next is write a line of code that prints the length of the existing list. So we have print the length of the list, which is hat list, and then print, we have here in line 10 print hat list. So print hat list, and then we run the code. So we enter number, let's say 9. So as we can see, the 1, 2, 3, 4, 5, the 3 was replaced by 9, and the element 5 has been removed. And now, thus the length of the list is only 4 because we have only 4 numbers, 1, 2, 9, and 4. And this is our resultant list. So pretty much good. Okay, so here's the code. Observation. So the elements inside a list can have order because 0, 1, 2, 3, 4, 5. Also, the counting of the elements starts from 0 on the leftmost element, incrementing by 1 to the right. 0, 1, 2, 3, 4, 5. However, the length of the list starts from 1, not 0. It is evident because we have here 4 elements, which is labeled as 0, 1, 2, and 3. But the length is still 4 because it starts from 1 and not 0. So, lists use square brackets instead of parentheses as opposed to functions. It is also observed that an element can be replaced by calling out the value of the element and replacing it with another, as we did here in this, because we call out 2, which is the value of 3, and then we just input the new replacement for 3. Okay, for our conclusion, For and while loops are codes that run continuously until a condition is satisfied. The difference can be seen on while loops that are generally used for executing codes until the condition returns false, because while the condition is true, it would run. But if it is false, well then, it would stop. The break statement forces the loop to stop and execute the code outside of the code, after the code. So the continue statement forces the current iteration to stop, the current time to stop, and then go back again to the start, and go back to continue on a new iteration. It is a new iteration. Okay. And then the elements inside a list can be accessed by counting the elements, starting from 0 on the leftmost element, incrementing by 1 to the right. Still, the length of the list starts from 1. Lists use square brackets instead of parentheses. That is all. Thank you.